Hello students. Hopefully you already watched the 2-minute video I gave you a link for that showed you what conic sections are. Conic sections are cross sections of cones. So we have the circle, the ellipse, the parabola, and the hyperbola. And so basically what we usually do is take one day to talk about each of these. And I just want to point out that when you have an ellipse, a parabola, or a hyperbola, the orientation could be different. So the ellipse could be tall instead of wide. The parabola could open right or left instead of up or down. In that case, it wouldn't be a function. Of course, the circle and the ellipse are not functions either. The hyperbola could open left and right instead of up and down. And also, there are conic sections that are on a slant. So for example, a hyperbola that opens kind of on a diagonal instead of left, right, or up, down. But we don't usually study those. So we usually focus on the ones that open just vertically or horizontally. Okay, so today we're going to talk about circles. And because this is a lesson for both pre-calculus and honors algebra 2, your notes number will be different. So I think that pre-calculus is on 52 and honors algebra 2 is on 57. And what we're going to do is look at the equation of a circle, and then we'll do some practice problems going back and forth from equation to circle or from important information to equation. So you don't have to write what you see on the first slide here. What I'm going to do is develop the equation of a circle, but just for a circle centered at the origin. So you see here I have a circle with center 0, 0. And let's say the radius is r. So I'll draw in a radius there. Now let's say that any point on the circle can be denoted as the point xy. Well then we have a relationship between r and x and y if we think about dropping a perpendicular, making a right triangle. One leg of the triangle has length x, one leg of the triangle has length y, and then the hypotenuse has length r. So according to the Pythagorean theorem, we have the relationship x squared plus y squared equals r squared. So that can also be used as the equation of this circle. So this circle is x squared plus y squared equals r squared. The equation of something, the equation of a graph, is just a relationship between the x and y coordinates. Now when you put the equation in that form, you call it standard form. So I'm going to refer to that as standard form. We like standard form because all you have to do is look at it and you can tell what the radius is and you can tell what the center is. Now, of course, not all circles are going to have their center at 0, 0. So what we do to generalize this is we imagine that the circle has been shifted, let's say h units horizontally and k units vertically. So now the center is the point hk. So this will be notes. Center is hk. The radius, let's say, is still r. Now, you know transformations well enough to know that if you shift something left or right, you just add or subtract to x. And if you shift something up or down, you just add or subtract to y. So that gives us this equation. X minus h, quantity squared, that represents the left or right shift, plus y minus k, quantity squared, that represents the shift up or down, equals r squared. And again, I'm going to call this standard form. Okay, so this is what you want to remember. The equation from the last screen is great, but remember it's only for circles with center at the origin. So this equation works for all circles, whether they're centered at the origin or not. So make sure you have that down and that you know its center is hk and its radius is r. Now let's do some examples. Okay, number 1, find the center and radius of the circle. Remember the equation, x minus h, quantity squared, plus y minus k, quantity squared equals r squared, where hk is the center. R is the radius. So what's the center? Well, h would be 3 and k would be negative 8 since we would have y minus negative 8. So the center is the point 3, negative 8. And what's the radius? Well, 12 is the radius squared, so then we square root that, and then we simplify it. So the radius is 2 square root 3. If you were graphing that circle, you would plot the center, In fact, let's go ahead and make some room for this. If you were graphing that, 3, -8. Okay, so let's just make a rough sketch. 3, -8, you would plot the center, okay? And then from there, you would approximate to square root 3. So what is that? Approximately, grab my calculator, square root 12, 3.5 roughly. So what I would do, of course, you'd be doing this with a little bit more precision, but from the center you would go up 3.5 and down 3.5 and left 3.5 and right 3.5, and then that would give you enough points that you could go ahead and connect them and draw your circle. Okay, number 2. Find the equation of the circle with center 0, -5 and radius 7. Well, again, let's use the form x minus h quantity squared plus y minus k quantity squared equals r squared. And let's substitute 0 and -5 in for h and k and 7 in for r. So we have x minus 0 quantity squared plus y minus -5 quantity squared equals 7 squared. And we're going to simplify that. So we have x squared plus y plus 5 quantity squared equals 49. And that would be the standard form equation. If it says what's the equation, assume that it means what's the standard form equation. Okay, now number 3. Now, it says find the center and radius of the circle, but this equation looks different. So this equation is in what we call general form. And general form has no parentheses and everything is all multiplied out. I'm going to talk more about general form in a minute. We have to go back to the form where we do have parentheses like this. So the way we go back is using your favorite algebraic technique, completing the square, good old CTS. Okay, so we're going to use the completing the square process. So let me remind you. First of all, you only have to complete the square if you have a term like this, 8y, 8x, 2x, something like that. If you don't have an x term or you don't have a y term, then you have nothing to complete the square. So because there's no x term, I don't complete the square on x, I just leave it as x squared. But I do need to complete the square on y. So I need to ask myself, how do I make this a perfect trinomial square? Y squared minus 8y plus what would be a perfect trinomial square? And I'm just going to go ahead and add 4 to get it over to the other side. And then, of course, whatever I add to the left, I have to add to the right. So how do I get a perfect trinomial square out of this? Remember, what you do is you take half of this number, we can call it b, half of b, and then you square it. So half of b would be -4, and we square it and we get 16. And that way we can factor this into y minus 4 quantity squared. So now we have x squared plus y minus 4 quantity squared equals what? Well, don't forget, if we added 16 to the left, then we add 16 to the right. So this equals 20. So here we have the standard form equation. And once you have the standard form equation, you can tell what the center is and what the radius is. So from this, we can tell that the center is the point 0, 4. That's our HK. And we can tell that the radius is the square root of 20. And we'll go ahead and simplify that, and that would be 2 square root 5. And if you were asked to graph it, you could graph it from there. All right. So let's talk a little bit more about general form in general, because you're going to have general form look the same for all of your conic sections. They all have a unique standard form, but general form is always like this. You have your x squared term, you have your y squared term, you may or may not have an x term, you may or may not have a y term, you have your constant, and then it equals 0. And you're always going to put the terms in that order. So for a circle, and only for a circle, you will see that a equals b. And in general, we like to have integers for a, b, c, d, and e, not fractions, integers. And I could make up all kinds of equations here, and put in random numbers, but that doesn't mean it's going to be a circle, because what if I put in a number that gave me like r squared equals 0 or r squared equals a negative? That wouldn't make any sense. So only certain values of e will make a circle. And then one thing I mentioned at the beginning, but it's not written here, is that order matters for these terms. So if we're putting our equation into general form, make sure you have the x squared, then the y squared, then the x, then the y, then the constant, then 0. Okay, so let's take a look at another equation in general form, and then let's change it to standard form and find the center and the radius. So once again, we're going to be completing the square, but notice there is an x term and there is a y term, so we're going to complete the square for x and we're going to complete the square for y. So I'm going to start by rearranging a little bit. X squared minus 5x, and then figure out what completes the square, and then y squared plus 8y, and then figure out what completes the square. And then I'm going to add 2 to both sides just to get it over to the other side, kind of get it out of the way. And then whatever I added to the left when I completed the squares, I'm going to add those numbers to the right. So again, looking at the x part, take half of this number. Don't try to do it with decimals. It is so much easier if you do it with fractions. So half of -5 is -5 halves. Square it, you get 25 fourths. Add that to the other side. And then for y, half of this number is 4. Square that, you get 16. Add that to the other side. All right, so now we write each of these in their factored form. So this perfect trinomial square here factors into x minus 5 halves, quantity squared. And then this one with y factors into y plus 4, quantity squared. And then we're going to add all these numbers over here. So let's see, we have 8 fourths, we have 25 fourths, and we have 64 fourths, I think. And so grab a calculator, add all this together, or do it in your head if you're a rock star, which I don't feel like being right now. Okay, 97 fourths. So here's our standard form equation. X minus 5 halves quantity squared plus y plus 4 quantity squared equals 97 fourths. And what's the center and what's the radius? Standard form, SF. Just looking at it now, we can see that the center, HK, is the point 5 halves comma -4. And we can see that the radius is the square root of 97 over the square root of 4. We can just call that 2. So then if you were going to graph it, you could use those values and plot the center and then approximate the radius and then show up that much, down that much, right that much, left that much, and you would have 4 points you could connect to make your circle. Okay, one more thing, 2 more things actually. There's, I think, 5 and 6 to go. So in this problem, we're given standard form and we're going to convert it to general form. Now, this is just an exercise in algebra, but most of the time you're not going to convert to general form because it's not very useful in terms of graphing or anything or understanding what's going on with the circle. But still, all you have to do to convert to general form is just multiply everything out. So we have to FOIL x minus 1 times x minus 1 and y plus 3 times y plus 3. And then we get x squared minus 2x plus 1 plus y squared plus 6y plus 9 equals 4. Now remember that the order of the terms matters in general form, so start with your x squared term, then write your y squared term, then write your x term, then write your y term, and then we're going to gather together 1 plus 9, and we're going to subtract 4 so that we have the 0 on the right. So this is going to add up to 6 equals 0, and there's our general form. Okay. And then the last thing I want to show you is how to graph a circle on your calculator. There's actually a couple different ways. When you graph on your calculator, typically you graph in function mode. And so right now we don't have a function. A circle is not a function. It fails a vertical line test. But our workaround for that is to make the top half of a circle, and that would be a function, and the bottom half of a circle, and that would be a function. So what we're going to do is isolate y. So we actually have a, we have a little bit of work to do before we put it in the calculator. So let's subtract x squared from both sides. And then let's square root both sides. And so what you can do with your calculator is you could let y1 equal the positive root and let y2 equal the negative root. So then let's grab a calculator. There's mine. So go to y equals, and I have the square root of 9 minus x squared. And then I have the opposite of, be sure to use the opposite button under the 3 and not the minus button, the square root of 9 minus x squared. Okay, now here's the thing. We know that this should look like a circle with what center? That's right, 0, 0. Remember the original equation was x squared plus y squared equals 9, so the center is 0, 0. And what's the radius? That's right, 3. Okay, so we know this should be a circle with center 0, 0, and radius 3. What happens if we go to Zoom Standard, our favorite viewing window, -10 to 10? There's the top half, there's the bottom half. Okay, it's stretched out just because the window is rectangular, so the spread of the units on the x-axis is different from the spread of the units on the y-axis. So you have to know that it's a circle even though it doesn't look like it. But one thing you can do instead of doing Zoom Standard is go to Zoom Square, number 5. So Zoom Square evens things out so that your intervals on x and y axes are equal, so that looks more like a circle. You might be asking yourself, why isn't it connected? Well, really in theory it is connected, so you should draw it connected. It's just that the calculator is thinking that it's vertical, and it's not going to draw it vertical because that would fail the vertical line test. So you just have to be a little bit smarter than your calculator here. Now some of you might just have differences in your pixels and you might actually have it look connected. Let's also try Zoom Decimal just for fun, number 4. And that also gives us a more, it gives us a good view of that circle, and it's evenly spaced, it's not skewed. Okay, and if I press trace, you can see the equation of the top half, that's the y1, the positive root, and the equation of the bottom half, that's the y2, the negative root. So now, your assignment is to do the circled worksheet, and as always, check answers, ask questions, send pictures. By the way, I wanted to mention that one of the things I think is really cool about this assignment is that here we are at the end of the year, but we get to incorporate things like completing the square, which really makes it feel like we have come full circle.